Hello and welcome class. In last class we have completed the first law of motion or law of inertia, and first law of motion says that if a body is in rest it will continue in the state of rest, and if a body is in motion it will continue in the state of motion unless an external unbalanced force is applied on it. And we have learned about inertia and tried to solve few questions. Now we will start in today's class the second law of motion. So let's begin the second law of motion by an introduction. So the first law of motion indicates that when an unbalanced external force acts on an object, its velocity changes. Why its velocity changes? Because that object will start accelerating or retardating. Okay, that is, objects get an acceleration in positive way or negative way. We would now like to study how the acceleration of the object depends on the force applied and how we measure a force. So in second law we will mainly concentrate on force, that how acceleration generate a force or how force produce an acceleration, and what is the relation between force and acceleration. So let's find the answer by some observation. During the game of a table tennis, if the ball hit the player, it does not hurt. Okay. In the game of table tennis, we all have seen or played table tennis. Uh, there is a small table, a small ball, and a small bat, and play it like badminton. Okay, and if by mistake the ball hits the player, it does not hurt the player. Or in the other hand, when a fast moving cricket ball hit the spectator, it may hurt him. Okay, why? A truck at rest does not require any attention when parked at along a roadside. When a truck is in the state of rest, it does not require any attention. Okay, okay, when it is parked along a roadside, but if the truck is moving even with a below speed of 5 meters per second, it may kill a person standing in its path. Okay, why it is so? A small mass such as a bullet may kill a person when fired from a gun. These observations suggested that the impact produced by an object depends on mass and velocity. Okay, table tennis ball is very less weighted, so it may not hurt the player. But in comparison to cricket ball, okay, it is the mass of cricket ball is very much higher than the table tennis ball, so it may hurt. Okay, the spectators. In the similar way, if a truck is standing, okay, it will not hurt anybody. Okay, but if a truck is moving with a low velocity such as 5 meter per second, it may kill a person. So we have understand that the impact of an object, how much an object can impact, depends on two factors. One is mass, second is its velocity. So impact depends on mass and velocity. Similarly, if an object is to be accelerated, we know that greater the force is required to give a greater velocity. If there is an object and you want this object to accelerate, so you have to apply a large force to make any object accelerate. In other words, there appear to exist some quantity which is the combination of mass and its velocity. Okay, there should be an quantity should exist which is the combination of mass and velocity, and one such property is called momentum, which was introduced by Newton. The symbol of momentum is P, and momentum is defined as the product of mass and its velocity. The symbol of momentum is P, small p, and it is defined as the product of mass into velocity, mass and velocity. Momentum has both direction as well as magnitude. Like acceleration, like velocity, momentum also has both direction and magnitude. And because the momentum p is the product of mass time velocity, so the direction of momentum depends on the direction of velocity, because mass does not depends on direction but velocity does. So momentum's direction also depend on the direction of velocity. The SI unit of momentum is, the SI unit of mass is kg. The SI unit of velocity is meter per second. So the SI unit of momentum p is kg meter per second. If we apply an unbalanced force to an object, its velocity changes. Okay. And if velocity changes, any object which has mass moving with a constant velocity, then it has momentum of mv. And if we apply a force on this object, if we apply force, then velocity is not constant. Velocity will start changing. It means momentum will start changing. Therefore, it is clear that force produces a change of momentum. If you apply force, momentum of a object will change. It means velocity of that object will get changed. To understand it, let us consider a situation in which a car, a car with dead batteries is to be pushed. This car is not working. Okay, it has some dead batteries, and you need to push this car along with a speed of 1 meter per second so that engine can get started. Its engine can get started. If one or two person give a sudden push, it is hardly starting. Okay, but a continuous push will generate, continuous applying of force will generate an acceleration, and that acceleration can give that battery that push so that the engine can get started. It means that if you change the momentum of the car, not only determined by the magnitude of the force, but also the time during the force is exerted. So, if you want to change the momentum of the car, you not only have to apply force, but you also have to apply that force in lesser time period. It may then also be concluded that force necessary to change the momentum. So it is clear to us that if you want to change the momentum, you have to apply force. That's why the velocity varies and depends on the time rate at which momentum is changed. So, okay. So if you want to change the momentum, you need force, you need time rate at which the momentum is changed. And the second law of motion talks about the relation between force and momentum. So, second law of motion, this is the definition of second law of motion. Second law of motion stated that the rate change of momentum means momentum divided by time is directly proportional to the applied force on that object. This relation is known as second law of motion, that rate change of momentum, it means momentum divided by time, is directly proportional to the force applied on the object, and this force is a unbalanced force in the direction of force. So the second law of motion stated that the rate change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. Now let's do some mathematics. Okay, what is the mathematical expression for the second law of motion? Suppose a object has mass m, its initial velocity is u, okay? It is uniformly accelerated. It is uniformly accelerated. It means you have applied a constant force, okay, and its final velocity is v after a time t. So, initial and final momentum of that object is, what is the initial momentum of this object? Initial momentum is mu, because momentum p is product of mass into velocity. So, p is the product of mass into times velocity. So, initial momentum at the beginning was mass into initial velocity, and momentum after is the product of mass into final velocity v. Now we know that change in momentum divided by time is directly proportional to force. So change in momentum will be equal to final momentum minus initial momentum. So change in momentum is directly proportional to P2 minus P1. What is P2? P2 is mv. What is P1? P1 is mu. M is common. Okay, so v minus u. And what will be the rate change of momentum or force? Force will be directly proportional to change in momentum divided by time. Okay. And according to first equation of motion, what is the value of v minus u divided by t? Okay, what is the value of v minus u divided by t? We know that v is equals to u plus at. So v minus u divided by t gives acceleration. So F is directly proportional to ma. And whenever you remove the proportionality sign, a constant occurs, and that constant here is k m a. Okay. The quality k is a proportionality constant. Okay. The SI unit of mass is kg. The SI unit of acceleration is meter per second square. The unit of force is so chosen that the value of constant k becomes 1. We have chosen all the quantities in such a way that the value of k is equals to 1. So if you want to calculate the force, okay, force is just the product of mass into acceleration. This is the formula for force. The formula for momentum is mv. And according to the second law of motion, rate change of momentum p2 minus p1 divided by time is directly proportional to the force applied to it. So these are the three formulas which you have to remember. Okay. And these formulas are derived because of the second law of motion. So K become 1, then force is equals to ma. Now let's calculate the standard unit of force. So we know that the unit of mass is kg and the unit of acceleration is meter per second square. But the standard unit of force is on the name of the scientist, Newton. So the unit of force is Newton and its symbol is capital N. So second law of motion provide how can we calculate how much force we have applied on an object. And the formula is just mass times acceleration of that body. Is it clear? So we first defined what is momentum. Momentum is product of mass times velocity. Okay. And according to second law of motion, change in momentum divided by time is directly proportional to force F. After calculation, we get that force is equals to K times ma. we have chosen the quantities in such a way that the value of k is equal to 1. So F is equals to ma, where the unit of force is Newton, written as capital N, or if you want to write full name, N should be small. The second law of motion is often seen in action in our everyday life. Okay, you can notice second law of motion in our everyday life. Have you ever noticed that when you wants to catch the cricket ball, the fielder gradually pulls his hands backward with the moving ball? Okay, he first catches the ball and then moves his hands backward. Why? Because if he will move his hand backward, then he will get more time and the velocity of ball will get decreased in a certain time. Okay, that's why fielder do use this trick to catch a ball with very high speed. If you become rigid, okay, and if you do not pull your hands back and try to stop ball in one position, your hands will be hurt because all the force will get impacted on your hand. To decrease the acceleration of the ball, okay, the or to decrease the impact of catching the fast ball, we have to increase the time period, and to increase the time period we used to move our hands in backward, pull our hands in backward direction. Is it clear, class? If the ball is stopped suddenly, okay, if you are not doing using this trick and the ball is stopped suddenly, then what will happen? So the velocity, let assume the velocity of the ball was 10 kilometer, let's say 100 kilometer per hour, and it becomes zero all of the sudden. So all the impact will be absorbed by your hand and you might get hurt or injured. Thus, the rate change of momentum of the ball will be large. If there is no time period, you haven't take time to decrease the velocity of the ball, then the rate change of momentum will be higher. And therefore, large force would impact your hand. Okay, the large force would have to be applied to holding the catch that may hurt the palm of the fielder. In the high jump, this is the case of the cricket. In other game, in the high jump athletic event, the athletes are made to fall either on a cushioned bed or on the sand bed. Okay. In a high jump athletic event, the athletes are made to fall either on the cushion bed or on the sand. Why? So that when they jump on the cushion bed, okay, cushion bed is thick. They have jumped, so they will take longer time to decrease their speed. And if they take longer time to decrease their speed, the impact will be lesser. This is to increase the time of the athlete to fall to stop after making the jump. This decrease the rate change of momentum and hence the force. If momentum decreases, the force will get decreased and you will injure less. Try to ponder how karate players break a slab of ice with a single blow. How a karate player break a slab of ice with a single blow, because they take very less time period to hit the uh, slab of ice. This is the example that if you want to catch the ball, you have to pull your hands backward to increase the time period. And if the time period will increase, then you will feel less impact because the momentum has decreased. Okay, according to the first law of motion, it is mathematically stated that F is equal to ma and a is equals to v minus u divided by t. Let bring t this side. So ft is equals to change in momentum. When force is equals to 0, it means that initial velocity is equals to final velocity. That it means that the object is continuously moving with a uniform velocity. So it means you can derive the first law of motion by using the second law of motion. Okay, what does first law of motion stated? First law of motion stated that if an object is in motion, it will continue remain in the state of motion unless and until an external force is applied on it. If you make the value of force as 0, it means if there is no external force, then initial velocity is equals to final velocity. It means that that object is continuously moving with the uniform velocity, or that object is doing uniform motion. It means that first law of motion gets verified using second law of motion. Let's solve one example. A constant force acted on an object of mass 5 kg for a duration of 2 seconds. Okay. A object of mass 5 kg for a duration of 2 seconds. Its velocity increases from 3 meter to 7 meter. Find the force. You have to calculate the force. If the mass of the object is 5 kg, if time taken is 2 seconds, okay, initial velocity is 3 meter per second, final velocity is 7 meter per second, okay, and you have to calculate force. Now, if the force was applied to the duration of 5 seconds, if the time period changes, what will be the final velocity? If initial velocity is same, force is same, mass is same, but time period changes, what will be the final velocity? You have to calculate it. How you're going to calculate it? We know that force is equal to change in momentum divided by time. Put the value of mvut, you will get force, and then using the same formula, put the value of f, m, u, and t, you can calculate final velocity. So, u is given, initial velocity is given, final velocity is given, time given, mass given. So we will use this formula, change in momentum divided by time is equals to force. So force is equals to 5 times 7 minus 3 divided by 2. So it will become 5 into 4 divided by 2, or 2, 5 to a 10 Newton. So the force is 10 Newton. If the time period changes, okay, force is 10 Newton, mass is 5. We have to calculate initial velocity, final velocity is 3, time is 5 seconds. We can calculate time. 5 5 cancel. So 10 is equals to v minus 3, or v is equals to 10 plus 3, 13 meter per second. Okay, class? So in today's class, we have studied the second law of motion, and we have mathematically formulated the formula of momentum, force, and we discussed where this information acts in our daily life. In next class, we will continue second law of motion and try to learn about what is third law of motion. I hope today's class is clear to all of you. Now we will meet in next class. Thank you.